Hello everyone, I am Dr. Imran Chandraki, working as an assistant professor and Dean PG program at Department of General Science Engineering, NB Nole Senior College of Engineering, Solapur. I have total teaching experience of 15 years and research experience of around 7 years. I did my PhD in mathematics from Dr. Babasaheb Ambedkar Technological University, Lonere in the year 2014, and now I have been recognized as a PhD guide at Punishloka Ahilyabai Road, Solapur University, Solapur. My area of specialization is applied mathematics, numerical methods, and boundary layer theory. And I have written 6 books, and I have published more than 21 papers in the journals and in the journals of national and international repute. So, in continuation with my previous lectures, I am going to talk on the multiple integrations, that is multivariate integral calculus. So let us see the properties, and then after we shall go for the problems. So in the previous lecture we have seen what is geometrical and physical significance of double integration, and then we have seen how to deal with the different concept, like if integration inner integration limit is in terms of x, it is limit for y, and if it is in terms of y, it will be limit of x. That's why first of all it is very much important to note what is inner integration limit is in terms of. So if it is in terms of x, it will be limit of the opposite variable. Obviously and naturally, if opposite variable is y, it will be what limit or y. Okay, so once you decide inner integration limit, you go for deciding outer integration limit then accordingly. So in the previous lecture we have talked about the properties. Once again, let us have a snapshot and the revision, small revision of the properties. So first property is double integration over the region R, f of xy plus g of xy or minus g of xy dx dy is same as double integration over the region R, f of xy dx dy plus or minus double integration over the region what R, f of xy gx, f of xy dx dy. So we can see that the meaning of this integration is double integration is distributive over addition and subtraction, as like your first single integration. And then the second property is regarding taking the constant outside the double integration. So if there is a constant involved in integrand, we can very easily pick up it outside the integration. That is the second property of double integration, as like your single integration. And thereafter suppose that your region of integration is like this, as shown in figure 7.1.3, and if you divide this region into two regions as shown in figure R1 and R2, this dotted line is indicating the strip. Okay, so this strip will move from left to right. Okay, so if it is a vertical strip, it will move from left to right, and if you have horizontal strip, it will move from bottom to top. Okay, so if you have strip, okay, like this, if you have so if you have strip, a horizontal strip, then it will move what in vertical direction like this. And on the contrary, if you have a vertical strip, yes, remember that within region of integration it moves from left to right. Okay, that will be the motion of strips, horizontal, vertical. So vertical strip will move from left to right, and horizontal strip will move from bottom to top. Okay, so after this, I think already we have talked about this part, that is strip parallel to x-axis, strip parallel to x-axis. You can even here observe that the vertical strip is moving from x is equal to a to x equal to b, while its motion lower end of the strip is on y is equal to g1 of x, and upper end of the strip is on y is equal to g2 of x. Okay, so we see that what this is the strip. Okay, and this strip is moving from x is equal to a to x is equal to b. Okay, while its motion lower end of the strip, you can check it out, lower end of the strip, okay, that is lower end is here, lower end is on lower end is on y is equal to g1 of x, and upper end is on y is equal to g2 of x. Okay. In similar way, if you look at the second figure, you will observe that in the second figure, in the second figure 7.1.2b, what we have written here, that the strip is parallel to x-axis, meaning is that this strip will move from bottom to top. Okay, so horizontal strip is moving from bottom to top. We can check it out. This strip, okay, will be having initial position here and final position here, and this is the arbitrary position. So strip is moving with what y is equal to c to y is equal to d. While its motion, what the inner end, okay, or you can say the left end, is on what the curve x equal to h1 of y, and the outer end, that is your right end, is on x is equal to h2 of y. So this strip moves from bottom to top, while its motion left end, right end, okay, bottom to top. Here what this strip moves from left to right, what the lower end, upper end. Okay, and then we will discuss about the property, like property of double integration, third property of double integration. If you split the region like this, then double integration over the region R, so double integration over whole region R, double integration over whole region R is will be equal to double integration over the first region R1 plus double integration over the second region R2. Note that here we have same integrand on both the sides. Okay, and here what strip is moving from left to right. If you take strip parallel to x-axis, it will move from bottom to top. Okay. After this, let us have first problem pertaining to your direct evaluation of double integrations. Okay, before that, let me clear out all of the profiles. So my first problem to evaluate a double integration is like this: integration from 1 to 2, integration from y to y cube. Note that here we have two integrations. One, which one is this integration? I am going to call it as the outer integration limit, where this what is the inner integration limit. Okay, so we have two integrations, one will be outer, other will be inner. So if you intend to evaluate any double integration, in that case you see what is inner integration limit in terms of. Okay, and you might have observed that the inner integration limit is in terms of what? Y. So we can observe that inner integration limit is in terms of y. So you can see that. So inner integration limit what is starting with y square and ending with y cube, and the integrand is e raised to x by y dx dy. Okay, so integrand is e raised to x by y. Note that e raised to x by y is depending on x as well as on y. Okay, and it is to the power of e. Now if what you decide to integrate this, then first of all you are supposed to decide what is order of integration. Order in the sense with respect to what you are going to differentiate. Here you have two differentials, dx and dy. So whether to integrate first with respect to dx or first with respect to dy, it will be decided by inner integration limit. And you can observe that inner integration limit is in terms of y. If it is in terms of y, what is meaning of that? It is what? Limit of opposite variable. Okay, that is the remaining variable. Which is the remaining variable? X is the remaining variable. I'm sorry, it should be x. So as inner integration limit depends on y, it is limit of x. And once we have limit of x, okay, for inner integration, definitely what outer integration limit will be for which variable? Y variable. Okay, so it is decided that what inner integration limit is for x and outer integration limit is for y. If it is in terms of y, it will be limit for x. If it is in terms of x, it will be limit. Okay, So first integration is with respect to x. That's why my order of integration is, first integration is with respect to dx and then with respect to y. Okay, then if you are integrating first with respect to x, the very first thing that you will be doing in evaluation is keep what dy terms outside the inner integration. So you can take dy terms. Now let us see how many dy terms are there. So we have what, a single dy term, and that is your dy, and only dy can be taken outside the what, inner integration, but it should be inside outer integration. You can check it out that the what dy term is constant for inner integration, because we are integrating with respect to x, y will be acting as a constant, therefore dy can be taken outside inner integration, but it will be inside outer integration. So you should not keep this dy here, that will be totally wrong. It should be inside what, inner integration, it should be inside outer integration, but it should be outside inner integration. Okay, that we follow here. Okay, so I am going to take this dy here. Okay, and we cannot take this y because it is to the power of x by y, therefore we cannot take this y outside. So I am going to keep and treat y as a constant. I am going to integrate, and we know that integration of e raised to x by y is what, e raised to x by y. Okay, so putting upper and lower limit, what we get, so integration. Now this figure we will take we will talk it about this figure later on after completion of this problem. Okay, why I had drawn this, actually this figure is not at all required, but for understanding what the concept of strip and the motion of the strip and the deciding double integration limit, it is very much essential. Okay, so anyway, and what you know that integration limit, integration of e raised to term, so integration of e raised to term is e raised to term, so integration of e raised to term is e raised to term, that is written over here. So integration of e raised to x by y is e raised to x by y. Okay, here one can see that x is constant, x is variable, y is constant. So if y is constant, 1 upon y is constant, so 1 upon y is as it is. Note that in integration we divide by derivative, and derivative of x with respect to is 1. So what, derivative of x by y with respect to x is 1 by y. In integration we divide by derivative. If it could be a differentiation, I would have multiplied by a differentiation. Okay, that is a chain rule. So what, denominator of denominator is y, which will become a numerator, and that's why integration value comes out to be y e raised to x by y. And if you put upper limit, what we get, y cube by y, which is equal to y square, that is written over here. Okay, and if you put y is equal to if you put x equal to y square, we should put what, x equal to y square. Okay, and we should put x equal to y cube, because we have just integrated with respect to x, therefore x should be replaced by upper limit and x should be replaced by lower limit. So if you put upper limit, we get y, yes, you can check it out, you get y e raised to y cube by y, and y cube by y is what, y square. So we get y e raised to y square minus, and if you put what, x equal to y square by y is y, so we get y e raised to y dy. And what, this integration is quite easy. The first integration can be done with the help of substitution, y square equal to t. So put y square equal to t, we get 2y dy is equal to dt. Okay, limit will be same, and you will find that y dy will be dt by 2. So we have simply integration of e raised to t, where t is y square, and integration of e raised to t is e raised to t. If you put upper limit and lower limit, we get the value equal to 1 upon 2 what, 1 upon 2 e raised to y square minus, okay, 1 upon 2 e raised to y square, and if you put lower limit, we get 0. So what, this is the value of first integration, and second integration is just case of integration by shortcut formula, integration by parts. The formula is like this, integration of what, uv, okay, so is equal to u what, v1. What is v1? v1 is integration of v. Note that if what, one term is exponential, other one is algebraic, yes, we can use the shortcut formula of integration by parts, and the formula is given by u v1 minus what, u dash v2. Okay, note that here the prime, that is dash, denotes differentiation, whereas v1 v2 v3 what, all are the successive integrations. So integration of v is v1, integration of v1 is v2, and what, so on. You can observe here or that what we have, alternative plus minus sign. So first sign is plus, second sign is minus, third sign is plus, and so on. Okay, so what we are observing, so see, if at this place I replace what, this u by what, y, and the second by e raised to y. Yes, what I will be getting, e raised to, that is y as it is, integration of e raised to y is e raised to y minus what, derivative of y with respect to y is 1, and what, integration of e raised to y again is e raised to y. And you will observe that next term what I have skipped, because what, derivative of 1 will become 0, and that's why your answer is what, y e raised to y. You can see y e raised to y and minus what, e raised to y, 1 times e raised to y. Note that here outside we have negative sign, therefore negative positive becomes negative and negative negative becomes positive, and if you put upper limit and lower limit, yes, we get the answer equal to this. Okay, so with that, what, simply we have evaluated the double integration, what, with the help of given order of integration, and given order of integration we have recognized by checking out what the inner integration limit is depending on. If it is depending on y, it is limit of x, and if it is what, depending on x, it will be limit for y. Okay, now let us go for discussing, yes, the figure. Why I had drawn this figure 7.1.1. Okay, this figure is required because one can note that this integration from 0 to 1 and y square to y cube e raised to x by y, yes, has the region which is bounded by 4 curves. Okay, so what that 4 curves are? So I am going to show it to you that the inner integration limit is in terms of y square, that is in terms of y. If it is in terms of y, it will be limit of x. Okay, so inner integration limit what becomes limit of x? Obviously the outer integration limit will become limit for y. Okay, so my region of integration is bounded by 4 curves, and that 4 curves are y is equal to 0, second curve is y is equal to 1, and my next curve is x is equal to y square, x is equal to y square, and the last curve is x is equal to y cube. Okay, so we can see that there are 4 curves. Now let us see what is geometrical meaning of these 4 curves. Okay, so first curve obviously is a circle, is a straight line. So y equal to 0 is equation of straight line. Obviously it is a very special line, that is your x-axis. You know that equation of x-axis is y is equal to 0 and equation of y-axis is what, x equal to 0. So it is equation of which axis? X-axis. So first curve is x-axis, second curve is what, again straight line which is parallel to x-axis at a distance 1. So this one is straight line, this one is also straight line. So these two are these straight lines, y is equal to 0 and y is equal to 1. Okay, and what, these two, okay, now you need to recognize this curve. Okay, this curve, this one is a parabola. Why, how it is parabola? X equal to y square, if one variable is having power equal to 1 and other is having power equal to 2. Okay, and if the variables are not in multiplication, then it represents a parabola. So y square equal to x is a parabola which is symmetrical about x-axis, since all powers of y are even, that we have seen in your curve tracing, Cartesian curve tracing. So this curve is symmetrical about x-axis. If x is 0, y is 0, equation satisfies, it passes through origin. And if what, if you put x equal to 0, y is 0, and if you put y is equal to 0, x equal to 0, so what, this curve passes only through origin, and after that you will find that the least degree term is x. If you equate x to 0, we get x equal to 0. X equal to 0 is equation of y-axis. So you will find that your curve, okay, your curve is a curve, this curve will be like this. Your x-axis, y-axis, okay, and this one is your rightward open parabola. You will find that for negative values of x, y square is, therefore this is your region of absence. Okay, this is your region of absence, and this curve passes through only origin, and it is having tangent at origin is equal to which axis? Y-axis, and therefore what you will be having a tangential region like this. Okay, so tangential, and due to symmetry again tangential, and that is a rightward open parabola. So first one is the rightward open parabola, and you will find that the second curve is not symmetrical about any axis. You will find that it is symmetrical in opposite quadrant, because if you replace x by minus x and y by minus y, you will find that negative negative get cancel, again you get same equation of curve. Therefore it is symmetrical about what, symmetrical in opposite quadrant. And if it is symmetrical in opposite quadrant, you will find that if x is 0, y is 0, y is 0, x is 0, therefore it is again passing through origin only. So second curve passes through origin only, this curve passes through origin only. Okay, and again it is having same tangent. Okay, same tangent, therefore your curve will be like this. So x equal to y cube, what you will be having a curve like this. Okay, so it will be absent in second and fourth quadrant. Okay, let me show this with the help of Mathematica software. Okay, so for you already I have made some arrangement. Okay, so I have shown it here. Now let me have this curve on xy plane. So you can check it out. This one is your parabola, the blue one is a parabola, and the pink one is a curve. Which curve? X equal to y cube. Okay, x equal to y cube. So if you want to have more insight of it, what you can have here, minus 3 2 plus 3 and minus 2 2 plus 2. So you can check it out. So this is one is the parabola, this one is the parabola. So this curve is a parabola. So this curve, the curve x equal to y square is a parabola, rightward open parabola. I think already we have discussed. And the second one is a what, curve x equal to y cube, and that is the second curve. Okay, and you can see that what we have two more curves, and that two more curves are that two more curves are y is equal to 0. You can check it out. This is y is equal to 0. Y is equal to 0 is the equation of x-axis, and this one. Okay, so this is y is equal to 0, and this one is y is equal to, this one is y is equal to what, 1, and this is your x-axis, y-axis, x equal to 0 and y equal to 0. Okay, so your origin of integration is here. How your origin of integration is here? Because this strip is moving like this from bottom to top. Okay, so while its motion, what, it will start its motion from x-axis, and equation of x-axis is y is equal to 0. That's why strip moves from y is equal to 0 to y is equal to 1. How y is equal to 1? If you find out point of intersection of what curve, solve these two equations simultaneously. So x equal to y square and x equal to y cube, you solve it, or x equal to y square and y equal to 1, you solve it, you get x equal to 1, y equal to 1. So this point of intersection is 1 1. Okay, x is 1, y is 1, and with that you will find that what, this strip moves from y is equal to 0 to y is equal to 1. While its motion, left hand is on parabola and right hand is on what, the curve x equal to y cube. So this we can see. Okay, let me first clear out the, so you can see the figure now. So your figure is like this. So this one is the parabola, and this one is y equal to x cube. Okay, here what we have taken a strip parallel to which axis? Here we have taken a strip parallel to what? So this is the strip which is parallel to y axis. This strip moves from what, y axis. So its starting point is y axis. So equation of y axis is x equal to 0. So x equal to 0, to note that this point, already I had declared that this point is which point, 1 comma 1. How we get this point 1 1, but that we will discuss later on. And this is obviously 0 0. Okay, so this strip moves from y is equal to 0, x equal to 0 to x equal to 1, while its motion lower end is on y equal to x cube and upper end is on y is equal to root x. Actually y equal to root x is nothing but what, y square is equal to x. Y square equal to x gives you y equal to root x. So upper end is on y. Therefore we got limit from what, 1 to 2 and y to. Now let us have second problem. So I am going to give this problem as a part of exercise. Okay, you can do it with the, in similar way this problem you can do. So first integration, you will observe that it will with respect to x. Why? Because the inner integration is in terms of y, therefore it will be limit of which variable, x. So if inner integration limit is of x, first integration is to be carried out with respect to x, and thereafter what you are supposed to integrate, what, with respect to y. Okay, so first integration is with respect to x, treat y as a constant, and integrate inner integration. What before that, what we take, what, dy outside. So dy should be outside inner integration, but it should be outside outer integration. Okay, so that problem also you can do. Now this one is a very typical problem. In this problem, you will observe that inner integration limit is in terms of, it is in terms of x, therefore it will be limit for which variable, y variable. As it is limit for y, first integration is to be carried out with respect to y. So what, y is variable, x is a constant. So in that case, what I should take dy, I should take this dy outside. So I should take this dy outside. So dy should be outside inner integration, but it should be inside outer integration. So with respect to inner integration, dx is constant, but with respect to outer integration, dx is variable, it is not a constant. So what should be taken outside, dx should be taken outside along with x raised to 1 by 3. So x raised to 1 by 3 is taken outside, dx is also taken outside, you can check it out. So that two terms, what they are taken outside, what they are taken outside, x raised to 1 by 3 dx is outside, and what remains inside is y raised to minus 1 by 3. This x we cannot take it outside. Okay, this is acting as a constant, so 1 minus x is constant. Now this integration can be very easily solved by just letting, okay, I am saying letting, not, it is not a substitution. Okay, it is just temporary adjustment. Okay, so I can call it as a temporary adjustment. So I am going to what, let or say 1 minus x equal to a. So here is your a, so this is a and this also is a. So integration now it becomes 0 to a, you can check it out, 0 to a, y raised to minus 1 by 2 a minus y raised to 1 by 2 dy. Okay, so this term is acting as a and this term is acting as a. So 0 to a, y raised to minus 1 by 2 a minus y raised to 1 by 2 dy. Okay, and now you can check it out that if I take a common outside, so a will take power of that bracket, it becomes a raised to 1 by 2. Okay, no, I can take a raised to 1 by 2 outside the inner integration, but it should be inside outer integration. A is in terms of x, therefore a is constant with respect to inner integration, but it is variable with respect to outer integration. So a raised to 1 by 2 is outside, so we have minus 1 to plus 1, x raised to 1 by 3, a raised to 1 by 2. Okay, so what, dx, and then y raised to minus 1 by 2 and 1 minus y by a bracket raised to 1 by 2. Now you will see that it is what looking like your beta function, provided limit should be from 0 to 1, and we have variable raised to power minus 1, 1 minus variable raised to power minus 1. So let us brought that form. So for that my substitution obviously will be what, put y by a is equal to what, t, or a new variable. So if I put y by equal to t, so if I put this, yes, it will give you that y is equal to 80 and dy is equal to 80t. Therefore if y is 0, t is 0, Okay, and if y is equal to a divided by a, that is a will get cancelled, t is equal to 1. So new limit will be from 0 to 1, this becomes 1, and y value is what, at. So a raised to half, a raised to minus half, t raised to minus half. Okay, this a already we have taken outside, and 1 minus t raised to 1 upon 2 into a dt. Okay, the simplifications will be like this. Okay, so x raised to 1 by 3, a raised to minus 1 by 2, a raised to plus 1 by 2 will get cancelled, t raised to minus 1 by 2, 1 minus t raised to 1 by 2 a dt. A is again constant that can be taken outside inner integration, but it should be inside outer integration. So x raised to 1 by 3, a is nothing but 1 minus x. Okay, so t raised to 1 by 2. Okay, so actually it is minus 1 by 2, but minus 1 by 2 can be written as 1 by 2 minus 1, that is plus 1 minus 1 I had it, and I got here 1 minus t raised to 3 by 2 minus 1, because 1 by 2 plus 1 minus 1 gives you 3 by 2 minus 1. So this is nothing but your beta form that can be simplified like this, and after this integration is quite easy, therefore integration is possible, and integration values are what written over here. Remaining part you can do it at home. So your final answer will is 9 pi by 28. Okay, now if you look at the next problem, okay, there are so many problems. Okay, all the problems I cannot discuss over here, so I insist you to try to solve all the problems yourself. So see which one is the variable for inner integration. If it is in terms of x, it will be limit for y, therefore first integration is to be carried out with respect to y. Okay, so there are so many problems, you can check it out. Okay, all have see, it depends on your capability and your sincere efforts to try to solve the problems. If you have any query, you can contact me. Now after this we are going to see the evaluation of double integrals when limits are not given. Okay.